There would be already a communication would be going on within the ISP, provider routers. We just have to enable. Just have to enable VRF, create a VRF for a particular customer. Suppose a new provisioning comes, right? So we have to create a VRF, call that VRF interface into that VRF, and then means advertise those networks into BGP.
Okay, yes, but I am confusing. Yes, you are correct, this one. But I am confusing, like, for example, R1 and R5. These are the other end, this other end. Let's say between there are one more router, R4. Is this also a provider edge router?
How many routers are there? Tell me here.
You can tell over here if we can discuss.
Yes, sir. Yes.
How many routers are there?
Yeah, for example, 4 routers.
4 routers. Okay.
Yeah, down there, please draw on down. Yeah, now this R1 and R4 is the PE router, right, sir?
Okay. You can configure R1 and R4 as a PE, or R1 and R3 can be also PE. R1 and R2 can be also PE.
But customer has to be directly connected on that.
Yeah. If here I have customer, A side 1 on router number 1, side 2 on router number 3. So one P is R1, another P is R3.
No, sir. There is one more router. One more router. Please. One more router. Please connect with the R3.
R3.
No, please connect with the R3. Yes, sir. Sir, my question is now. This one, let's say what the name?
R6.
Yeah, R6. Yes, sir. Now this R6 also PE router. R1 also PE. R4 also PE. Now, for example, R1 I created a VRFA. If same name, maybe someone will create on the R6 also. Then how R4 it will identify?
So
this is my
here I have confusing. 3 PE, na? P1, P2, and P3. P3. For an example, here I have side 1. That is your scenario, right? Here side 1, here side 2, here side 3.
Yeah.
Right. So all are P. Here we will have BGP neighbors. If for an example, here I have one BGP neighborship between P1, P2, one BGP neighborship between P2 to P3. I can configure out reflector here. So like side 1 is here, side 1, side 2, and side 3.
Side 2, okay, sir.
Side 3, correct? Here I have VRF A. Here also I have VRF A. Here also I have VRF A. Here I am advertising, customer is advertising one subnet 10.1.1.0/24. It will advertise to P1. P1 will advertise to their neighbor to P2. And here by default it will not advertise to other IBGP neighbors. If you will configure out reflector, then it will advertise. Or we can have one BGP session here between P1 to P3 also.
R4 and not. Yeah.
Full mesh.
Okay. Okay, sir. One small confusion here. For example, R1 now this site 1. Let's say this one company name. This one company A.
Okay.
Or something name.
Yeah. Company A.
Okay, sir. Yeah, company A. Let's say R6 company B.
Okay.
Now, yes, sir. Now the company A and the company B is connected other end with the R4.
R4. Company A and company B.
Yes, sir.
Okay. Fine.
Yeah. Now my little confusion is here. R1 I have created VRFA. Maybe R6 also someone will create a VRFA for company B.
Okay.
And then this R4 router.
Okay, Karthi, your question is that how come we can make sure that there should not be any existing VRF on the device, right?
Yes. R4 how it will distinguish.
No, like he's saying company B is also using same VRF, A VRF.
Yeah, yes, yes,
On single
exactly, sir.
router, brother, how two company can use same VRF? That is not
VRF
possible.
name has to be
It
unique,
can
like
use
router
VRF
ID.
C instead of VRF A. Company B can use VRF C. Here he can use VRF B. No problem.
Yeah, this is, yeah, okay, okay.
If
I got
somebody
it.
create by mistake same VRF, he will
Yeah,
use
yeah,
the
this
other
is,
pair.
yeah, this is what I'm asking, because there are multiple
How you
routers,
will
right?
create same VRF twice? IP VRF A. This command will create VRF A on here. How I will create duplicate VRF of A?
Bro, and
I,
before creating any VRF, you have to run command show IP VRF. So you will be creating the VRF which is not there in that VRF list.
yes, IPVR of A we have created on R1 only, but R6 also we will create a IPVR of A, or let's say example, for example. Then coming to the point R4, both VR of A it will come from R1 also, and R6 also it will come, both VRA it will come to R4.
VRF.
Sir, he's saying that VRF A is created on R1
Hmm?
as well as on RA, right? So if we'll
R6.
talk about R6, so R6
Yeah.
would be receiving VRF A from R1 as well and VRF A from
No, no, no,
R4
no,
as
No,
well.
no, no.
bro. Router
R4.
4
R4
don't
will
know.
receive.
Router 4 don't know what VRF here you are using, right? How it is injecting the route in VRFA with the help of RT value, not by using VRF. Same
Yes, yes.
customer A side 1 can have VRFA here, and here they can have VRFB also,
Correct. Is the question.
right? Whatever RT value I am exporting over here, same RT value R4 should import in this VRF.
Yes, correct, correct. This is my question. Yes, exactly.
Sir, I have a question regarding VRF.
Hmm?
Sir, recently in my place where I work in, the I don't know if my question is related to switching or is it routing, but VRF is there. I need to understand the concept. What was the concept? We are dealing with, our site has switches from Alcatel, so the command line is very like difficult to
Show router
understand. So
something. Yeah,
they
show
came
router.
and implemented this VRF. The architecture is as so. We have two-tier design. There are like 20 buildings. Okay, every building has access switches and one distribution switch. And then that distribution switch is connected to a central data center. The core switch is there. So recently we said that all the VLANs, every floor has, every access cabinet has separate VLAN. So they said that we will implement VRF on the distribution switch. So all the VLANs are going to go through the VRF and will be connected to the core switch. How is that scenario possible? I just need to understand how is it possible?
Okay. So here I have, let's say, 2 access layer switch and 1
Yes,
distribution layer switch.
exactly. Yes.
Okay.
Yes.
Here I have another building also here. Building 2. Switch 1. This switch. Access layer switch 1. Here I have some VLANs. VLAN, let's say VLAN 10 and VLAN 20. And gateway of these two VLAN is distribution switch 1, right? Here I have interface VLAN 10, where my subnet is, for an example, 10.1.1.0/24. Done. For VLAN 20, my LAN subnet is 20.1.1.0/24. Done. And we need to steer these two LAN to distribution switch 2.
Sir, if you can draw a core switch in between, it will be better, exactly as we have right now.
How many core switch? 2 core switch or 1 core switch?
Suppose, let's say there is one core switch.
One core switch, okay. Fine.
Yes.
Sir, is the session being recorded?
Yes. Core switch 1. I have one core switch between distribution switch 1 and distribution switch 2. Now I want to advertise these two LAN subnet to distribution switch 2. How many paths is here? Only one path. What I can do? Guys, what I can do? I can create two VRF here, VRF A and VRF B. I can assign VLAN 10 interface to VRF A. I can assign VLAN 10 interface to VRF A and VLAN 20 interface to VRF B. And then we can enable MPBGP between distribution switch 1 and distribution switch 1. 2. Here I can define the RD value and RT value to import and export. So between distribution switch 1 and distribution switch 2, we can advertise all the VLANs prefixes separately through MPBGP. Yes or no? The configuration and concept, everything is going to be exactly same. Here I can create one loopback 1.1.1.1, and here I can create one another loopback 2.2.2, and between 1.1.1.1 and 2.2.2 I can have one MP. There is no any difference, brother, in this scenario.
There is another addition. They are, as per their information, they said that we are doing like VRF Lite. So there is no BGP involved, and switch, suppose distribution switch 1
Okay.
and switch 2, they don't see each other. Only distribution switch 1 and the core switch, they see each other.
Okay, then also no problem. Here VLAN 10 interface and 20 interface is already there. Here also I can
Yes.
get VLAN 10 interface and VLAN 20 interface. I will here also assign VLAN 10 interface to VRF A and VLAN 20 interface to VRF B.
Okay.
That's it. We can configure any protocol here. For VRF A, I can configure OSPF process
So-
1. For VRF B, I can
With core
configure
switch,
OSPF
with
process
core
2.
switch,
So on
with core switch.
core switch, what will we do on core switch, sir?
OSPF only. This link is trunk link. This link is trunk link. This link is also trunk link. Here I will create two SVI, VLAN 10 and 20, and I will enable OSPF. I will advertise both the interface in OSPF.
So do we need to create sub interfaces between the core switch and distributed
On all the
switch?
switch, you have to create sub interface. Then only you will enable the OSPF, na?
Yeah, that is why I'm asking. Yeah.
Yeah. From the trunk link, all VLAN traffic can pass.
So
So
there will be no VRF created on core switch.
No?
Okay.
Why VRF you will create on core switch? It's not required, na, brother?
Sir, how core switch will decide to which VLAN it will forward the traffic of VRF
Tagging.
A, suppose. Coming
Tagging.
traffic
Tagging.
for V.
Core switch don't need to do anything with VRF. If you are running a OSPF for a single VRF, guys, then OSPF, in the OSPF prefix is going to look like IPv4 prefix only,
Correct, not VPN V4.
not VPN v4 prefix. So this is simple routing and routing only, routing and switching.
Maybe while doing switching, we can have this scenario.
Yeah, and till then, if you want to perform right now, you can do it in the UNG. You know how to make reachability between distribution switch and core switch. So first make
Yeah, it will be
reachability
something.
and enable the routing protocol. This is exactly similar like our topology of VRF Lite,
Correct.
right? Even
But sir,
if you don't need to enable OSPF on the core switch, then also it is possible.
Yeah, this is what I was asking. Without any routing protocols, because there is no routing
Then you
protocol
have to
being
use
used.
BGP. Because
there has to be some protocol.
between undirectly connected network, we cannot run IGP protocol. Right?
No,
Between
we don't want. In our scenario, the distributions, they don't talk to each other. Every distribution is a separate building. So these distributions, they don't talk to each other. All of them, they talk to the core switch.
Then this is perfect solution. The configuration. What I am saying, apart from your scenario, right, your organization, we can have guys direct to BGP neighborship here. Right, one for VRFA, one for VRFB. Or better to configure
Sir,
MPB.
In case there is like a firewall involved, because right now in our topology, the VLANs, they don't talk to each other unless the firewall allows it.
Okay.
So
So
in
what will
that
happen
case,
if I will put firewall over here? No worry. Then also concept is going to be same. Even firewall is there, load balancer is there, IPS, IDS, any device is there, doesn't matter, na?
So OSPF will be enabled between firewall and distributed
Distribution
switch.
to firewall, then firewall to core layer switch, core switch.
Okay.
Okay. Sir, I might check the configuration again, and if you give us 5 minutes, maybe in next class we might discuss it again.
Sure.
Thank you, sir.
Okay. So in the last class, what we had seen, we have exchanged the route, but ping was not working. Correct? Because route was not there in the P router. Correct? In the customer network, guys, we were able to find the prefixes, remote site prefixes, but ping was not working. Correct? And after enabling MPLS, even ping was also working. So let's understand, after enabling MPLS, how routers were forwarding the traffic on the basis of label. So guys, for an example, here I am going to design one simple topology of 4 to 5 routers, R1, R2, R3, R4, and R5. And here I have one LAN, and here I have one LAN. Are also sufficient. For the LAN, between the router, we'll use same IP schema. Like between router 1 and router 2, my subnet is going to be 12.1.1.0/24. Between router 2 and router 3, 23.1.1.0/24. Between router 3 and router 4, 34.1.1.0/20. Here in this LAN, I am running, let's say, subnet 10.1.1.0/24, and here my subnet 1.1.0. 40.1.1.0/20. Guys, after enabling OSPF, how many routes will be there in the routing table of router 1? 10.1.1.0/24, 12.1.1.0/24, 23.1.1.0/24, 34.1.1.0/24, and 40.1.1.0/24. Right? This is the routing table of R1. R1 routing table, correct? In the routing table of router 2 also we will have same prefixes. In R2 routing table. In R3 routing table also we will have same subnets, same prefixes. And in R4 routing table also we will have same prefix. Clear? After enabling any routing protocol, this will be the routing table of your routers. Am I right? Yes, na? ये होगा ना routing table सारे router का, right? And router will check this routing table to forward traffic. Let's say 10.1.1.1 is going to ping 40.1.1.1. Router 1 will check this routing table. It will compare 40.1 with routing table, and here is the route. Here is the route. So all routers will compare destination IP with routing table and then forward the traffic. That is called which type of forwarding, guys?
IP forwarding.
IP forwarding, right? Or process switching, or you can say fast switching. Another type of forwarding is, I told you in last class,
Forwarding.
this is forwarding traffic by checking RIB table, right? And another type of forwarding is with the help of FIV, that is CEF, right? And third type of forwarding is MPLS, called labeled forwarding. Labeled forwarding, right? So now question is, where is the label, Praful? Where is the label? So once we will enable MPLS, let's say on router number 1 I have enabled the MPLS. What router 1 will do? Router 1 is going to assign one label to all the prefixes. Whatever prefixes are present in the routing table, it is going to add one label, right? If I will talk about the label size, guys, so it is, label is 20 bits decimal value. So what will be the range of label? Range is going to be 0 to 2 power 20.
20, yeah.
So from this range, it is going to assign label to the all routes present in routing table. For an example, for this prefix 10.1.1.0/24, router 1 have added one label, that is, let's say 10. Right? For 12, it have added one label, that is 11. Right? Even we can define the label also on the router, that you should use label from this range. Right? But right now I'm talking about by default, right? I have not configured anything, just I have enabled the MPLS. Then it can assign label from any range, any label from the range, right? So label for this subnet is 12, label for this subnet is, let's say, 13, and label for this subnet is 14. In the same way, router 2 is also going to add label. It can also add same label 10, 11, 12, 13, 14, or it can add another label also. For an example, 21, 22, or 20, then 21, then 22, then 23, and 24. Right? Router 3 is also going to add label, let's say 30, 31, 32, 33 and 34. Right? Router 4 is also going to add label. Let's say their label is 40, 41, 42, 43, and 44. Done. Now, like router have exchanged the routing table. Guys, before running routing protocol OSPF, in the routing table of router 1, there will be only 2 subnets, 12 and 10. Right? How router is going to learn these all subnets? Through routing protocol. Through routing protocol, we are exchanging the routes. In the same way, now we need to exchange these
Labels.
Right? Actually, this table is called LIB table. This table is called LIB.
Label information base.
Label information base table. And now router need to exchange these label with each other. Right? So like to exchange prefixes, we have routing protocol. In the similar way, to exchange label between the router, I have one. By the way, I have 2 protocol, but generally we are using LDP. This is LIB table. Right? To exchange this label, I have 2 protocol. First one is TDP. TDP, that is called tag distribution protocol. But it is Cisco proprietary protocol. TDP is Cisco proprietary, means you can enable it on Cisco devices only. Another protocol is LDP protocol, which is the popular one and open standard. And LDP protocol only we are using. We are using LDP protocol for label exchange, and LDP stands for label distribution protocol. Right? And it is open standard. Open standard protocol. So what will happen when you will enable MPLS on the router? Automatically LDP protocol will enable on the interface, and router 1 and router 2 is going to form LDP neighborship. What will happen here? We will have LDP neighborship, and all the router is going to exchange their LIB table with the help of LDP protocol, like router exchange routing table with the help of their neighbor. In the same way, with their LDP neighbor, router is going to share LIB table, exchange LIB table. Router 2 will have how many LDP neighbor? 2. One with router 1, one with router 3, and router 3 will also have 2 LDP neighbor, one with router 2 and one with router number 4. So all the router will have LIB table of each other, right? All the router will have LIB table of each other. Router 1 is going to receive LIB table of router 2, and router 2 is going to receive LIB table of router 1 through LDP protocol. And then router will calculate remote label. And it will build LFIB table, which it will use to forward traffic. Which table?
LFIB.
LFIB, label forwarding information base. Right? How? Guys, you know routing protocol, any routing protocol, EIGRP, OSPF, for example, EIGRP. First EIGRP will topology table, and after that routing table. In the topology table, it is going to store all the prefixes. In the routing table, it is going to store best prefixes. OSPF is going to first build database where it will store all the path, and then it will create routing table where it will store best path. In the same way, in MPLS, router is going to create what? LIB table, where we will have all the label, and in LFIB table we will have best label. So first of all, let's talk about LIB table in more detail. After the exchange, router 1 will have one more label here for this prefix. Which label? Remote label. See, this label 10 is 10, 11, 20. These are the local label of R1, local label. And the label which it is going to receive from the neighbor is called remote label. So what will be the remote label for 10.1.1.0 guys on order number 1?
20.
20. What will be the remote label for 12 subnet? 21.
21.
22. 23.
23. 24.
And 24, right? So there is only one remote label, right? It is not going to select best label, right? If there is only one path, then that path is the only best path. But what about router 2? On router number 2, how many remote labels will be there?
2 remote labels.
This is
One
local
from
label.
R1 and 2. One for R1, one for R3.
Yes. And remote label. Remote label for 10 prefix. 10 and 30.
30.
Right? For 12, 11 and 31. For 23, 12 and 32. For 34, 13 and 33. For 40, 14 and
34.
similar way on router number 3, we will have 2 remote label, local and remote label, 20 and 40, 21 and 41, 22 and 42, 23 and 43, 24 and 44. Actually, this is LIB table. This is LIB table. Here also, these are the local label. And remote label. How many remote label I have here? Only one, because there is only one LDP neighbor, and remote label is going to be 30, 31,
30. 32, 33.
32, 33, and 34. Right? And now all the routers are going to create LFIV table. How it will create LFIV table? This is LIB table. Fine. How routers have built LIB table, guys, with the help of LDP protocol. Either it can use LDP protocol or TDP protocol. And now it is going to create LFIV table. Means where it will store the best label only. Where it will store best label. So if I will talk about R1.
So suppose there is an additional router with R3, so another remote will be added, remote label.
R3 will have?
Suppose right now R3 has 2 neighborships with R2 and R4. Suppose there is an R6 also with R3. So another remote label will be added?
Yes, of course.
Okay.
Local and remote both.
Okay. Now, router 1 is going to find best remote label. And guys, router will always use remote label only to forward traffic. But all the remote label are best label on router number 1. Yes or no?
Yes.
On router number 2. On router number 2, it will check 10 subnet 10.1.1.0/24. There are 2 remote label. Now router need to find best label. How it will find best label? It will check their routing table, SAP table. In the SAP table, from which neighbor this 12 or 10 subnet is reachable? Which is the best path for 10 subnet, guys? Router 1 or router 3?
1.
Router 1. So whatever label it have received from the router 1, that will become best label. Means it is going to be what? 10. Best label for 10.1.1.0/24 will be what? 10. Right? For 12 subnet. 12 is directly connected network. Soon you are going to understand, for directly connected network, even router are not going to add the label. Right? Router will send implicit null label for directly connected network. Right? But let's understand first this concept. Okay. For 10 subnet, best label is going to be 10. For 12 subnet, for 12.1.1.0, which is the best level,
Again
11
10.
or 13, 31?
Oh, sorry, 11.
For 23, 12. For 34,
So for 23,
not directly connected are there. So they are
okay.
23.1.1.0. Here it is going to be 32. Okay. For 34 network, guys, 34.1.1.0, it will check routing table. In the routing table, best path is reachable via R3. From R3, which level it is receiving? 34, 33, 33. So that is going to be best level. And for 40 subnet also. Okay. This is LFIB table of router number 2. Similar way, router 3 is also going to get LFIB table. In the LFIB table, best remote level is going to be what? For 10 subnet, 40 or 20?
20.
20. So 20 is the best level. For 12 subnet, 21 is going to be best level. For 23,
22.
22. For 34 and
43.
for 40,
43.
40.1, 40, 44. Right? Similar way, router 4. On router 4 for 10 subnet, there is only one remote label, right? So that will be the best for all the prefixes. There is only one LDP neighbor. These are the LFIB table of your routers. And now router is going to use this LFIB table to forward the traffic. For an example, there is one user whose IP address is 10.1.1.1 who is going to ping 40.1.1.1. That will forward traffic to router number 1. Router 1 will check destination IP address because this is normal IPv4 packet, right? Not labeled packet. So router will again check SAF table, or you can say routing table. In the routing table, it will find exit interface. Exit interface is F1/0, and once router will see MPLS is enabled on F1/0, router will encapsulate router will encapsulate this packet. It will add the label. Which label? It will check their LFIB table. And what is the label in LFIB table, guys? For 40.1.1.0. What is the label?
14. 14.
24.
24 is the
24.
label.
Yes.
Right, so it is going to add label what? 24, and then it will forward traffic to router number 2. Now router 2 is going to receive which type of packet? IPv4 packet or label packet? This is label packet, right?
Correct.
Yes.
So router 2 will directly look up their LFIB table, not routing table, not RIB table or FIB table. In the LFIB table, it will compare the label 24 label, right? Where is the local 24 label here? And what is the remote label? 34.
34.
For 24 local label, remote label is 34. So router 2 is going to swap this label to 34 and it will forward traffic to router number 3. There will be, you know, in LFIB table, there will be exit interface also corresponding to routing table. From the SAP table, it will also copy exit interface. Now when router 3 will receive it, again router 3 is going to receive labeled packet. It will look up there, it will compare label with their LFIB table. In the LFIB table, it will find 34 local label. So here is the 34 local label and remote label is
44.
44. So it will again swap the label 44 and it will forward the traffic to router number. This way router is going to now forward the traffic by checking LFIB table instead of checking routing table. By the way, here router 3 will get to know that here I need to remove the label. Router 3 will not forward label packet to router number 4. What I told you guys, for directly connected prefixes, router are not going to share label.
Null label.
Right? So router 1 is not going to send label for 10 and 12 subnet. Router 1 is not going to share any label for 10 and 12. It will send label implicit null. Implicit null. So router 2 will not receive remote label for 12 and 10 subnet, right? So 10.1.1.1. This will be not the label and this is not going to be label here. In the similar way, router 4 is not going to send label for 40 and 34 subnet. So in the LFIB table of R3, we will not have remote label for 40 subnet and 34
Subnet.
Right? So when router 3 will receive it, when it is going to compare the local label is 34, which is coming in the packet, in the label packet, it will say, okay, there is no any remote label for this local label. So router 3 will get to know that I need to pop the label here. I need to remove the label and router 3 will send normal IPv4 packet. And router 4 will compare destination with routing table. It will forward traffic to user. Right? So these two are edge router. LSR, edge router. So edge router, one edge router is going to add the label and the last edge router is going to receive normal IPv4 packet. Between edge routers, all the routers are going to forward traffic on the basis of label by checking this LFIB table. Any question here to understand this?
Sir, I have one question regarding when we get it the prefix of 10.1.1.0, why it null for the R2?
Directly connected.
But it directly connected to R1, not R2.
R2 is not sending null, na? R1 is telling to router number 2 that brother 10.1.1.0/24 is directly connected to me. Don't send any labeled packet for 10 subnet. Right? That's why it is sending implicit null. Router 4 is sending implicit null for 40, means 40 subnet is directly connected to me. Do not send label packet for 40 subnet. Router 1 is saying do not send to label packet for 10 subnet to me, and router 4 is saying to their LDP neighbor do not send label packet for 40 subnet to me. It is directly
40 and 34, right?
Yeah.
Both.
Correct.
So it means when the last router which are directly connected that share as a null implicit for the next of the hope of the router, right? It means R2 or R3 because R2 or R3 are sharing that LFIB table, right?
All the routers are sending LIB table. The router 1 is sharing the label for rest all prefixes for 23, 34, 40. It is only not sharing label for directly connected network. Like router 2 will not share label for 12 and 23. Router 3 will not share label for 34 and 23. Router 3 will not share these two label and router 4 will not share label for these two subnet. They are directly connected subnet.
Okay, got it, sir.
So I have a question. Can we enable the LDP between RN and FAR4 directly,
No,
like BGP we did?
no. What is the benefit of doing that? Why you will enable LDP directly between router 1 and router 4?
Sir, to avoid this LFIB, and because see again it would be consuming CPU utilization for
So what
all the
will
routers
happen
in the network, right?
after enabling LDP over here? Router 1 is going to share label to R4, R4 is going to share label to R1. How this router will
Correct.
forward the traffic on the basis of label?
So these are, you can say, SP routers, right? So SP router uh, need not to know about what is being exchanged between the PE to PE, right?
No, here on
It
the
is not.
router number 2 and router number 3 only I don't have route, na. So here I need only label. What I want, let's say this is guys P router PE1 and PE2. So here is there any benefit of exchanging label between PE1 to PE2? PE1 have already route the customer prefixes. It can forward the traffic. These router cannot forward traffic. These are the P router. So that's why we have enabled MPLS, so that these two router can forward traffic on the basis of label. Even route will be not there in the routing table of R2 and R3. It will be forwarding the traffic. But if label is not there, then how these router can forward the traffic? You are taking it in wrong way, Rahul. Nothing will happen after by enabling LDP between router 1 and router 4.
Mhm.
There is no any logic. Nothing is going to be happened. Why will exchange label between router 1 and router 4? If router 4 is
So,
going to share label for 40 subnet to R1, let's say label number is 10. So when R1 will forward traffic to 40 subnet, it will add label 10. It will forward to router 2. And how router 2 is going to swap the label? Even router 2 is going to discard it because LDP is not there, label is not there.
mhm. So you mean to say MPLS is means enabled on directly connected interface?
MPLS is
Means R1 and R2 directly connected, and same subnet is there between R1 and R2.
yes. It is similar like your IGP protocol, right? Like
Okay.
we are running
Okay.
IGP to exchange routing table. Here we are using LDP protocol to exchange the label.
Okay.
Even we don't need to enable LDP, once we'll enable OSPF, automatically LDP protocol will enable.
Okay.
Sir, I have a question regarding MPLS. That we performed or we introduced MPLS to solve a problem which was like 32-bit IP was taking a lot of time for the processing. So they came up with the MPLS. But MPLS is still 20 bits. So there is not such difference like 32 bits and
There is
20
huge
bits.
difference between 32 and
20.
20. Huge difference is there, brother. Around we have reduced the around 40 more than 40% CPU. We have reduced more than 40% of CPU on the router. Yeah, anything
And
else?
sir, on R3, while forwarding the traffic from 10 to 40, and R3 will not, R3 will be popping up the label, right?
Yes,
Because 40, because it has received from R4 that this is my directly connected network, right?
correct. R3 will pop
So,
the label for
sir,
40 subnet and R2 will pop the label for 10 subnet.
correct, correct. So this is only we call it PHP, right?
Yes,
Okay.
the popping process is called PH.
Sir,
On the, yeah.
sir, R1 it has multiple VRF means so R1 it will identify for each VRF it will separate it will give the separate label for each VRF. Then it will forward to R4 like this it will work.
Yes, exactly. If now here I have two VRF, right? In VRF A, there are 1000 number of prefixes. So for all 1000 number prefixes, it is going to add label.
Okay.
So here we can see the implementation. The router, guys, who is adding the label, right? Like when 10.1 is going to ping 40.1, which router will add the label? Router 1 will add the label because their exit interface is MPLS enable interface. R1 will add the label. So the router who is going to add the label is called imposition process. And the router who is going to swap the label is called swapping process. Right? So R1 is going to add the label. R2, R3 is going to swap the label. R3 is going to pop the label. Even both the router R2 and R3 is going to pop the label. Right? And if I will talk about the TTL value, so inside the IP packet, TTL value is going to be same, right? Router is not going to decrement in TTL by 1 because router is not opening the IP packet, right? Earlier router were opening IP header to check the destination IP address. Now router is not checking IP packet. Router is only checking what? MPLS label. That's it.
The source MAC and destination MAC will still be used here?
Yes. Definitely, whenever router will forward traffic from the Ethernet link, it will add Ethernet header. Source MAC and destination MAC is still here, exactly same. What is happening here? See, first we have IP packet. In the IP packet, source IP for 10.1, destination IP 40.1, it will forward to router 1. Router 1 is going to check destination. It will find this interface, exit interface. MPLS is enabled over here, so it is going to add, encapsulate this IP packet to MPLS header, right? Where is the label info? And then it will forward to router. Router 2 will again check label, this field only. MPLS header only. It will not check IP packet. So whatever TTL value is there inside the packet, only router 1 have decremented in TTL by 1. Right? So if you are going to run trace route command from 10.1 to 40.1, you will not discover these two routers. My point. Guys, in trace route, only TTL or trace route work. We had a session for trace route, right, earlier. Router will be generating lots of traffic, UDP based traffic, first with TTL1, then TTL2, then TTL3. With the help of TTL value only router is discovering the hope. Right? So here when I will trace route, will only discover router 1 and router, will not discover router 2 and router.
Why, sir?
Because what I told you, TTL value is going to be same na, in the IP packet. Router 2 is not going to decrement in TTL.
Okay. It will not be opening the IP packet.
Yes. Right. So even in the IP packet, TTL value is, let's say, 1. Then all of this packet can travel from R1 to R4.
Okay.
In the normal IP packet, if TTL value is 1, then it cannot travel from R1 to R4.
Yes, sir. It will drop at our only.
The implementation.
Sure, sir.
Actually, when I am saying, brother, implicit null, right? So, like when you will learn MPLS in the service provider network, like that is the use, right? A separate course. You will learn in the implicit null, actually routers, your edge routers are sending label 3. Label 3 is one different label in MPLS, in the LDP, right? And whenever router will say label number 3, right, it will get to know that I need to pop the label. That is called PHP process, popping, label popping, right? For now, it is so simple for you to understand, like directly connected routers are not going to share label, any label for directly connected routers. but again this is not true. It is sending label 3, that is implicit null. So when router 3 will see, okay, label number is 3 for 40 subnet, that means I need to pop the label. When router 2 will see, okay, label is 3 for 10 subnet, that means I need to pop the label, right? Some labels are reserved. From the range 0 to 2 power 20, some labels are reserved here, which we don't need to discuss now, right? This is more than sufficient for. Now here you need to see the implementation, that's it. So what I can do here, either I can create some VRF customer, or I can simply enable the MPLS over here and one OSPF protocol there. But we will not advertise 10 and 40 in OSPF. Then also it will, ping will work. Then also ping will work. What I am saying here, we can enable OSPF between router 1 to router 4, but we will not advertise this LAN subnet in OSPF. So router 2 and router 3 will not have route.
Correct.
Right? Then also it can forward the traffic on the basis of label. Or here you can make this network as a complete like core service provider network. You can create multiple VRF here. You can configure MP, BGP. Then you can enable MPLS. So let me do one thing. Let me access these all routers and let's configure it. First of all, I am going to configure any IGP protocol.
Sir, can we do this lab with VRFs? एक दफा रिवाइज भी हो जाएगा VRFs. Kindly.
कर लेना आप.
आप करेंगे तो ज़रा चलेगा.
मैं कर दूंगा. Interface F0/0 no set and IP address 10.1.1.1 255.255.255.0 exit interface F1/0. पहले तो आप ये बताओ कौन सा IGP प्रोटोकॉल चलाएंगे?
सर वो स्पेस चलाएंगे सर.
255.255 IP OSPF 1 area, right? Router OSPF 1 router ID 1.1.1. So IP face brief. So IPF interface brief. Router 2 config T interface F0/0 search address L.1.1 255. Yeah. To exit interface F0/0 IP OSPF 1 area 0. Now I am expecting OSPF neighborship here. To so IP OSPF neighbor. क्या neighbor आप आने वाला है? It interface F1/0 no such IP address 23.1.1.2 255.255.255.0 IP OSPF 1. Yeah. G. R3 config T interface F0/0 router OSPF 1 OSPF 1 ID .3. Face F0 no such IP address 23.1.1.3 255.255.255.0 IP SPF 1 area. By the way, network type भी configure कर देना चाहिए filter करने के लिए. कौन सा LSA filter होगा? If I will configure network type point to point here, which LSA will be filtered?
LSA 2.
What is the name of LSA 2?
Summary LSA sir.
Network LSA.
Sorry, network
Network LSA.
Network LSA.
Interface F0/1 1/0 search IP address .1.4 255.255.255.0 so IP F1 area. So exit face F0. that, and IP address 40.1.1.1 255.255.255.0. So IP OSPF neighbor, so IP OSPF neighbor जल्दी आ जाए हमारा। So IP route OSPF. So 23 and 34 submit are coming through OSPF routing protocol, correct?
Correct, sir.
अब क्या करना है?
MPLS.
MPLS. Let me take you to R1 and config T interface F1/0 MPLS
IP.
S, right, and so MPLS ये भी पढ़ा तो LDP कैसे काम करता है। तो MPLS LDP पर कोई नेबर नहीं है, तो
सर अभी R2 पे नहीं
MPLS
करा मैंने बोल।
LDP binding. This is the command to check what? LIB table. Right? Here you can see for 10.1.1.0 label is for 12.1.1.0 label is implicit null. For 23.1.1.0 label is
16.
For 34.1.1.0 label is
17.
Right? And now router 1, once it will discover LDP neighbor, it is going to clear this label table to R2. And this is the label table, right? Here you can remove label 4, 10 and 12. If I will talk about the LDP protocol, guys, so LDP is an application layer protocol. LDP is application layer protocol which uses TCP or UDP. Which protocol?
TCP.
TCP.
Sir,
TCP
BGP
and
we have learned.
port
BGP.
number?
Sir, 643 I think.
ये भी याद नहीं है 43 646 I think
666 correct.
so R1 I2
सर TCP बोला था मैंने एप्लीकेशन लेयर में मैंने BGP से रिलेट किया था बेसिकली
so first it will again send SYN message router 2 will send SYN plus ACK and it will send acknowledgement. After that we will have TCP connection SYN plus ACK and after that over this TCP connection it is going to send their actual message, right? Okay guys, we can have L पर also राहुल ने पूछा था रिसीव कर सकते but यहाँ कोई लॉजिक for an example here I have 1.1.1.1 loop back and here we can have LDP neighborship between loop back. After enabling the LDP, what will happen? Both are going to send hello message. We'll check some parameters and then both will become अब इतना पैरामीटर ये वो सब इसी तरीके से let's do one thing here. Let's enable LDP protocol on router number 2 also, right? There is one command to check the neighborship, to verify the LDP, right? I have already shown you the LDP binding, right? Neighbor is not there. We can check the LFIB table also by running command show MPLS forwarding table. This command will show you the LFIB table, forwarding table, right? The best table. Okay. Now go to router number 2, and here I am going to enable this on F0. So first MPLS interface F0/0 MPLS
IP.
globally we enable कर सकते. Now here you can see the log message LDP neighbor. Who is neighbor? 12.1.1.1. This is router ID, right? Router ID concept is similar like OSPF router ID or BGP router ID. If loopback is there, then loopback IP address will become router ID. Okay. Or on router number 1, here I can configure it as well. For now, so IP, so MPLS, LDP. So you can see the neighbor information. Router ID of router 2 is 23.1.1.2. Okay. So LDP identifier, neighbor peer LDP identifier is this one, and local LDP identifier is 12.1. So router 1 is using what LDP router ID 12.1, router 2 is using what LDP router ID 23.2, the higher IP address, highest IP address. Okay, and it is TCP connection. Fine. The port number here you can see 646. Source port number is random port number. Fine. State is okay. Okay. Source fast is 30. Fine. Everything is. Now let me enable LDP on another interface as well. Interface F1/0 and MPLS IP. And before enabling MPLS between router 2 and router 3, here I can show you the binding table, means LIB table. So MPLS LDP binding. This is LIB table of router 2, binding table of R2, and so MPLS forwarding table. This is LFIB table, right? So there is one label for 34.1.1.0, that is 16. Who is advertising this label? Who is advertising this label, guys?
R3.
R2. Sorry, R1. R1. On R1 should see the binding table. Binding table for 34 subnet local label is 16, right? So this label is based on router number 2 for now, because router 2 have not received label from router number 3 till now, right? Because we don't have LDP neighborship between 2 and 3, correct? And apart from the label, you can see the exit interface is also there, and next hop IP address is also here, right? On router number 1 also you can check. This is binding table, and here you can have forwarding table. It is popping the label. Router 1 is popping the label for which subnet? 23.1.1.0, because router 2 will not advertise any label for 23 subnet, right guys? So router 1 will pop the label. Hope it is clear till here. Now I am going to enable MPLS between router 2 and router 3 also. Interface, and on router number 2 we can verify one more thing. So MPLS forwarding.
सर enable नहीं किया अभी.
Router number. So MPLS forwarding. Here you can see I don't have any label for 10 subnet 10.1.1.0, right? And so IP route. In the routing table also you can see 10 subnet is not here. Here. Now go to router number 3 and interface range F0/0 and F1/0 MPLS IP. Go to router 4, interface F1/0 and MPLS and go to router number 1, ping 40.1.1.1, source 10.1.1.1. क्या ping work करेगा?
सर आइडियली तो आईपी फॉरवर्डिंग के हिसाब से तो नो
नहीं करेगा, राइट? बिकॉज राउट ही नहीं है. So
बिल्कुल.
through BGP between router 1 and router 4 we will have BGP session. For now I am going to add a static route, let's say 40.1.1.0 255.255.255.0 and exit interface f1/0. Next of IP address 12.1.1. And on router number 4 config t IP route 10.1.1.0 255.255.255.0 f1/0 and 34.1.1. Now will ping work? Working.
नहीं सर R2 और R3 R2 और R3 के पास में नहीं है.
R2 और R3 के पास तो कभी होगा भी नहीं. R2 R3 के पास कभी होगा भी होगा. की राउटर के पास राउट होगा क्या? तो IP staff 40.1.1.
फॉरवर्डिंग टू 12.2.
तो MPLS forwarding table. First try to understand the forwarding table, guys. See here the forwarding table of router 1. On router number 2, earlier in the forwarding table for 34 subnet table was 16, and so forwarding table for 34 subnet table is 16, and next hop IP addresses means this neighbor is also advertising same. Earlier next hop router 3.
So, sir,
LS
for
for 34 advertising dot forwarding table for 2. Just a minute. Forwarding one thing, face 050 face 0 LS LDP पर
और चाहिए
face F1S तो
सर वो स्पेस देखना इनके बीच में.
जब तो है face F0 से face f0 slash. Now let's troubleshoot the LDP neighborship between daughter 3 and daughter 4. Here on daughter number 2, so LDP, so MPLS LDP neighbor. Here I am expecting 2 neighbor. Fine, one is 12.1 and another one is 34.3. Correct. On daughter number 3, so MPLS LDP neighbor. There is only one neighbor, 23.2. Face 4 dot 4 face 1 slash. So SAP must be enabled for the MPLS, because by checking SAP table only it will select the best label, right? In the SAP table it will compare the route, right, from where it is receiving best route, and from the same neighbor whatever label it is receiving, that will be. So MPLS interface, okay, daughter number 3, so MPLS face can enable LDP through OSPF also. Router OSPF 1, and here I can say MPLS LDP auto config, right? So it will enable MPLS on all OSPF enabled interface. Interface F1/0 LS router F1 interface F1/0 face F1 face 50 face F1 bug config समझ गया इशू face 4.4 5.5 1 exit face F
सर कौन सा इंटरफेस पे डाला हमने 4.4
अब LDP neighborship up आ गया. Now LDP neighborship is up. So what was happening earlier? Router 4 had selected their LDP router ID what 40.1.1.1, right? So in the SYN message, source was 40.1.1.1, which was not reachable from router number 3. So whatever router ID guys router is going to select, that should be reachable. What I told you, between router 1 and router 2, if here I have one loopback 1.1.1, here I have one loopback .2.2.2, and after enabling MPLS on this interface and this interface, LDP neighbors will not come up, because router 1 is going to elect 1.1.1 as router ID and router 2 is going to elect 2.2.2 as router ID. So in that case 1.1.1 and 2.2.2 should be able. Okay, and now I am going to verify the connectivity. So LS LDP binding, S binding for now. There is your ICMP packet. Are you able to see source 10.1 destination 40.1?
Yes, sir.
Is there any label? With label packet or normal packet? Is normal IPv4 packet, right? Label is not there.
Yeah.
Config did. So run section IP route and added one static route. Router number 4 also. And IP. Now base F0 MP50 face F0. So on router number 1, I will have one label for 40.1.1.0 subnet or not? 40.1.1.0. No, because that route is not there in the routing table. But guys, if I want to make reachability between these two customers, now what I can do? Just think what we can do here.
You can make a BGP.
Can make BGP, right? So on router number 1, I can get one loopback interface, loopback 1 IP address 1.1.1.1 55255.255.255, and on router number 4, one loopback is already there. Go to R1, a router BGP as number 100 and neighbor 4.4.4.4 and remote AS is, for an example, same IBGP and neighbor 4.4.4.4. Update source loopback. Go to R4 config T router BGPS number 100 and neighbor 1.1.1.1, remote AS is 100 and neighbor 1.1.1.1, update source back 1. So directly R4 is going to advertise 40 submit to R1 and R1 is going to advertise 10 submit to R4. Correct? So IP route on router number 1. So IP route BGP So IP summary. Okay. Why my neighborship is idle? Because 1.1.1 and 4.4.4 are not reachable. So IP OSP of one area 0, and soon my BGP neighborship will come up. Just wait. Okay. Now you can create n number of VRF on daughter 1 and daughter 4. So IP route BGP. So IP BGP network 40.1.1.0 mask 255.255.255 dot R1 router BGPS number 100 and network 10.1.1.0 mask 255.255.255 dot. So IP BGP done, and so IP route done. Now ping 40.1.1.1 source 10.1.1. Ping is working, and see the capturing. Where is the capturing, guys? Capturing. Start the cap. Here you can see your packet now. Okay. Again, I am going to send ICMP packet. Here is your ICMP packet. Open it and see. ICMP packet, IP header, MPLS label, and Ethernet header. Clear? And in this MPLS header, what it's sending? It is sending label. It is sending label. This is MPLS TTL value. An experimental bit, S bit, forget it. There are some extra informations. The LDP.
Sir, why it is working with BGP before you put static route? That time it wasn't working.
Static route also it will work. Here on daughter number 1, guys, I am going to create one loopback number 10, IP address 50.1.1.1 255.255.255.0, and on daughter number 4 interface back 10, IP address is into what? Dot 1.1.1 255.255.255 dot, and IP route 50.1.1.1 255.1.0 255.255.255. Router number 1, IP route dot 1.1.0 255.255.255.255.0, and next of IP 4 ping 60.1.1.1 source 51. Interface back 10, yes, paste paste dot static 50.1. face face back one thing router
Sir,
the loop back
on the
interface.
R4, static route is the wrong, sir, on the R4. You have mentioned 255.255.255.255.
No
That's
worry, I
why.
have removed the BGP. So IP BGP. Now here you can see I'm not learning BGP. Going to remove from here also router BGP 100, and I'm going to add a static route now on router 1 IP route 40.1.1.0 255.255.255.0 and 4.4.4.4. The R4 IP route 10.1.1.0 255.255.255.0 and next up 1.
Sir, R4 static route is configured wrong, sir.
10.1.1.0 255.255.2. Correct, na?
No, sir, for the 50 subnet.
On R1.
Yeah, R1 we have created 50 subnet with 255.255.255.0, but you have to make a
So
routing.
slash 32. So slash 32.
Yeah, slash 32.
40.1.1.0. This one is the
Sir, interface way. Sir, interface way. Can you check the loopback interface mask?
loopback का क्या जरूरत है? मैं तो ये वाला 10 submit और 10 and 40 के
Sir, ping again, sir, it will work, sir. Because previously you was ping on 50 subnet.
oh one course thing is working. So ऐसा आप खुद से दिमाग लगा लोगे कि बीजीपी है इसलिए काम कर रहा है, स्टैटिक में काम करेगा, सब में काम करेगा वैसे ही. Doesn't matter what protocol we are running, right? That's not matter. How 40 subnet is reachable from router number 1, and all these routers, router 2, router 3 will forward traffic on the basis of label. See, when I am pinging 40.1.1.1 and this time I am not running BGP, okay? I am running a static route 50. What will happen? Router 1 will check what, guys? So MPLS forwarding table, right? And for 40 subnet 40.1.1.0, so IP route, router will check routing table, so IP route or SAP table, so IP SAP 40.1.1.0. and what is the label for 40 subnet?
17.
Right? So it is going to add label what? 17 here. You can see the in the capturing also the MPLS. Label is 17. So source IP 10.1.1.1, destination IP 40.1.1.1, and label is 17, and exit interface is, so IP F this one, exit interface is F1/0. Router 1 will forward from this interface after adding Ethernet header. When router 2 will receive it, Router 2 is going to check your forwarding table. So MPLS forwarding table. In the forwarding table, it will compare label 17. Where is local label 17? Here it is. And what is the remote layer label, outgoing label 16. So router is going to swap the label. It will change label to 16, and then on router number 2, then exit interface is F1/0. Forward the traffic from here. Router 3 is going to receive label packet. So router 3 will also check LFIB table. So LS forwarding table 17. Outgoing label is 17 only here. Router 2 at 7. Right, and then it will forward from F1/ next hop IP address you can. Now when router 3 will receive, it is receiving labeled packet, right? Guys, router will receive this traffic, right? Packet, this one. So first router will check Ethernet header, then router will check MPLS header, and on the basis of MPLS header only router will forward the traffic. Router is not going to check these two, IP header and ICMP protocol. So router 3 is going to check label is 17. So MPLS forwarding table for local label 17, I need to pop the label, I need to remove the label, I need to forward traffic from fast Ethernet 1/0 next hop IP address 34.1.4. Router 3 is going to remove the label and it will send normal IPv4 packet to router number 4. So router 4 is receiving unlabeled packet. Router 4 will check SAP table. So IP SAP 40.1.1.0. Okay, this network is directly connected, right? So IP route 40.1.1.0. This network is directly connected on fast Ethernet 0/0 router 4. Right? So you can see on router number 2. So IP route 40.1.1.0. Network is not in table or 10.1.1.0. So this is guys MPLS forwarding. Now we can create n number of VRF here and we can have one BGP session through which we can exchange all the company prefixes. Right? Now if this is service provider, then service provider is going to form MP BGP between P to P, right? This can be side 1 of customer A, this can be side 2 of same customer. So on router number 1, I am going to run router BGP AS number 100 and then address family VPN v4, or here I can say neighbor 4.4.4.4 and remote AS of neighbor is 100. Right? This is for what? IPv4 prefixes, for IPv4 prefix advertisement, and neighbor 4.4.4.4 update source loopback 1. Update source loopback 1, and then we can say address family VPN v4 neighbor 4.4.4.4. On router number 4 also we can run this command, and even I don't need now access of router P router wider router, the console of and R2 router BGP number 100, your neighbor 1.1.1.1 100 and neighbor 1.1.1.1 source back 1, then address family v4 neighbor 1.1.1. So now we have MP BGP between 1.1.1 and 4.4.4. Right? So guys, here for an example, this is interface F0/0 is a part of one VRF A, IP VRF A, and RD value 1:1 and route target value 100:100 for both import and export. Then interface F0/0 IP VRF forwarding. IP VRF forwarding A IP address 10.1.1.255.255.255. This dot it and router BGP number 100 address family NV4 sorry 4 address family IPv4 cast via A and network 10.1.1.0 mask 55255.255.0 and now you can check router 4 so IP BGP VPN IP
Sir, all summary. We have VPN v4 as well as direct.
why it is not advertising to router 4 because of VRF. The VRF is not exist
Not created. Yeah, VRF is not created on R4.
on router number 4 for customer. Okay, I can VRF here IP VRF let's say P RD value 1:1 and route target 100:100 both and interface F0 IP VRF forwarding five dot then submit is coming right here. I can advertise 40 submit router BGP number 100 address family IPv4 unicast VRFP work dot 1.0 mask 525.255 dot P for all right on one also you done. So this way we can have n number of customers here and for each customer we can configure the VRF, we can exchange here and customer prefixes will not be in the routing table of any provider router, but all the provider router will be forwarding traffic on the basis of yes. वगैरह now you know I am not available till 25.
From when, sir? From which date? कौन सी तारीख से?
So today is our last class.
नहीं.
Not last, like
So
after 25 we will continue again.
Yeah, from 25 only will continue. From 25 or hardly from 26.
Oh,
Okay, till the time we'll revise all this.
So tomorrow there will be no class.
Tomorrow,
Sir,
day
for
after
the
tomorrow, means till 25, right?
sir, for the eBGP also this it will be possible, right, sir?
Yeah.
This scenario.
Yes, of course.
Different service provider also different service provider
Yes, between
from.
different service provider also.
Uh,
You can create that type of topology, right? If there are multiple service provider,
okay, sir.
right? Maybe router 4 is connected to another service provider here,
Okay,
right? So you will have here IBGP, then you will have eBGP between service provider.
got it, sir.
If I have multiple IBGP, see, if I have multiple IBGP for VPN v4, then again we have to configure route reflector. Like in normal BGP, what we did, we configure route reflector here to break the rule. Similar way here also we can configure route reflector. All the concept is going to be same. BGP concept is same. The only thing is here in MPBGP, MPBGP is going to advertise VPN v4 prefixes and your BGP, normal BGP advertise IPv4 prefix. In the same way, if you want to advertise IPv6 prefix, so through address family, you can configure BGP for IPv6. For IPv6, if I want to configure BGP, I can say router BGP number 100 and address family IPv6. So what it's saying, IPv6 is not enabled till now here on this router. That's why we are not able to run. But
Okay.
once we'll enable the IPv6, after that we can change the address family and then we can define the neighbor command. Right? The BGP working is going to be exactly same for all the address family. Difference is IPv4 BGP is going to advertise IPv4 prefixes, IPv6 BGP is advertise IPv6 prefixes, MPBGP is going to advertise VPN v4 prefix.
All more topic है, how to study.
वैसे कल tomorrow my flight is around 10 p.m. So till tomorrow we can have class. If you want, we can start the edge technology. For 1.5 an hour we can have session tomorrow as well. It is possible.
Okay, sir.
Yeah, fine, sir. Okay.
Can cover at least NAT, and then when I will back, after that we'll continue VPN.
Okay, Wilbur. Sure.
Okay. So tomorrow we have class. After tomorrow we will not have class. Okay. 25.
सर ये वीडियो डाल दो आप.
हाँ सर,
ये वीडियो.
आज का वीडियो अपलोड कर दीजिएगा प्लीज.
अब आप लोगों को MPLS वगैरह सब समझ में आ रहा है ना, कैसे फॉरवर्डिंग हो रही. यही सब चीजें हैं मेन. वो EHRP वगैरह का कोई यूज नहीं है, बता रहा हूं मैं ज्यादा.
Okay.
8:30.
Okay, powerful. Thank you.
अभी मार्केट में OSP ये BGP और BGP चल रहा है ना.
सब कुछ.
Yes.
प्राइस में OSP BGP.
SWN and
वही तो मेन अभी के टाइम. अभी आप 3-4 साल के बाद ना हर जगह पे SD-WAN, जहाँ भी थोड़ा सा का साइड छोटा, अगर छोटा भी है 10-12 साइड है तो फिर आपको मिराकी दिख रहा है अभी. और फ्यूचर में for up to 50 sites, everywhere you will see the Meraki, and if we have more than 50 sites, then everywhere you will see the SD-WAN, and in the LAN SD access.
Okay.
Within 3 to 4 years, almost all the company will shift their infrastructure. Very repeatedly organizations are shifting, right? But to understand those technology, if you know the MPLS, VRF, routing, switching, understanding SD-WAN is just a piece of cake, right? I can teach you the entire SD-WAN in just 4 class. Trust me. The entire topology. You can set up it, design it, configure it, implement it. If there is problem, you can troubleshoot it as well. It's so easy. Right?
Okay,
but mandatory.
कोई फास्ट ट्रैक बैच इंट्रोड्यूस कीजिए ना फिर इसके लिए. कोई फास्ट ट्रैक बैच इंट्रोड्यूस करिए ना इसके लिए फिर.
5 टैग की बैच है, ड्यूरेशन लिखा रहता है कितने ही दिनों का। जब मैं 5-6 क्लास हो जाती है, खत्म हो जाता है, फिर मैं भी सोचता हूँ यार अब क्या पढ़ाऊँ।
नया बैच स्टार्ट।
मेरा कोई भी एसडी वैन में मैं 12-13 क्लास से ज़्यादा तो पढ़ा ही नहीं पाया हूँ, है ही नहीं, क्या पढ़ाऊंगा।
अच्छा,
जो भी अपनी टेक्नोलॉजी है ना, वो यही है सबसे मेन। ये क्लियर है तो सब कुछ आप सीख सकते हो, सब कुछ।
ओके।
2-3 घंटे की आप एसडी वैन की क्लास लेके आप खुद बुक वगैरह से एसडी वैन पूरा पढ़ सकते हो। अगर एक आपको पाथ मतलब ओवरऑल टेक्नोलॉजी को बता दे कि भाई वो कौन सी प्रॉब्लम को सॉल्व कर रही है, राइट, आप ये समझ जाओगे बहुत अच्छे तरीके से कि वाई, कहाँ पे मुझे जरूरत है। देन आई विल गिव यू वन बुक एंड यू कैन रीड इट बाय योरसेल्फ एज वेल। बट अगर आपको MPLS ही नहीं पता है, आपको BGP ही नहीं पता, OSPF ही नहीं पता है, तो कोई भाई का लाल नहीं है जो आपको एसडी वैन पॉसिबल ही नहीं है, राइट। क्यों? और ये सब चीज़ें जितनी अच्छे से आती है उतना आसान है वो सीखना, कोई भी टेक्नोलॉजी। मैं सिर्फ एसडी वैन की बात नहीं कर रहा हूँ। और